BOINC is a solution to distributed computation that is used by many research projects as a replacement for computations using supercomputers. BOINC cluster of computers consists of one workload server and one or more client computers that run BOINC client software. The platform is very flexible, but it is also rather complex to tackle directly. So instead, we're going to use a ready-made solution that allows us to create distributed computation tasks in the form of containerized applications. The solution is called BOINC to Docker, and it has been developed by Marius Milia, who is cosmologist and BCCP fellow at Berkeley Center for Cosmological Physics. This solution is used by Cosmology at Home project, in which researchers run complex models of universe development to find out which ones suit the existing measured data such as star positions and relative velocities better. BOINC to Docker includes docker-compose.yaml configuration file that sets up BOINC server for you with minimal effort, and a helper script that allows you to create a task based on any public Docker image, such as the one we created in previous part, distribute it to any number of clients, and instruct them to run a specific command within that container. On the client side, the process starts by client connecting to the workload server and polling available tasks. Then the client downloads the task information, detects the need to download a minimal virtual machine that contains Docker server and Docker image from public Docker repository. Once both are downloaded, the client starts up a VirtualBox virtual machine with Docker and runs the container based on the provided image and command specified in the task. One important notice here is that you cannot unfortunately run BOINC client that will perform BOINC to Docker tasks on ARM processor in a virtual machine or on a 32-bit machine, because VirtualBox images needs to be run from non-virtualized environment and is only available for 64-bit x86 platform. You will also need to be administrator of your computer to be able to install VirtualBox and allow BOINC to create new virtual machines. These limitations are in line with 64-bit Windows and Linux being the most common operating systems for BOINC clients. The task can store the results of its execution into a special folder as files. The contents of that folder and the values output by the command are compressed into an archive with results of execution and are uploaded back to BOINC server, which then marks the task as complete and returns results for server administrators access. Let's have a look at this Docker Compose YAML file that sets things up for us. Before we start installing BOINC server, we need to ensure that our virtual machine has its ports forwarded correctly. We will also add another port forwarding rule. For example, we can use port 3080 to redirect requests to guest machine at port 80. The port 80 is a standard port for web servers, and we're going to use web servers because BOINC server is providing its information over standard HTTP protocol. So we save this and return to our PuTTY interface. Here, first of all, we need to clone the repository of BOINC server. To do that, we are going to use git command, which is pre-installed in Debian. Git is a version management system that is frequently used in software development. And in this case, we're going to use it to just copy the existing repository with full information, get the latest version of it, and save it on our machine. The path is https://github.com/marius311/boinc-server-docker.git. And we run this command, and it creates a new folder. If we list, you can see that it has created boinc-server-docker folder, and we change our directory into that folder. Then we need to update all the dependencies of this system. To do that, we're going to use git submodule update command, and we're going to use flags init and recursive to update all chains of all submodules in this repository. And it takes slightly longer than the first cloning because the actual large piece of code is the BOINC itself. And when the cloning of submodules have been completed, we can now proceed. The first thing that we need to do is to replace the existing docker-compose.yaml with a slightly modified version that I have already tuned for the purpose of this course. You can get one from Moodle, and then you will need to put it into the folder which you have mounted as a shared folder into this Docker container. In case of Docker on Linux, you need to just clone this repository in whatever folder you find available, and you will just need to download the file and replace it directly. For other students, we need to go to the course, download the Docker Compose for BOINC server, save it, and then move this file to the shared folder. I already have done that. If I change my user to root by typing sudo bash, and if I go to the mounted folder, in my case it's sf_code, then I go to i2cs folder, and here I already have the docker compose.yaml file. So I copy this file into path home user, which is a username, BOINC server docker, and I exit root. So what do we have in the docker compose? Let's have a look at it with Nano. Docker Compose is effectively a configuration file that defines different services that are created as Docker containers, and they are what is called orchestrated as a single service. In this case, we have following services. They are listed here in YAML format under the key services. So we have MySQL, make project, and Apache. In addition to services, we also have the following volumes defined. So we have MySQL volumes that will contain MySQL database, project volume that will contain project information, and secrets volume that contains the pre-generated secret codes and other authentication tools that we actually not going to set up anyway. For each service, you can see the following patterns. First of all, there is a key for image. This field specifies Docker image tag that will be pulled from public Docker repository. In this case, it's BOINC. And then there is build context information. Volumes, they are mounting this particular folder that is on the right side of the column inside the file system of the container to this volume that we have defined here. This is just some container that has this var-lib-mysql, which typically contains database files preserved between recreations of this container. For Apache volumes, it shares project and secrets with other containers. It also mounts dev-null for the run secrets key code sign private, which is basically a file that it uses to generate private key of encryption, and in this case it just sets it to nothing. And then docker sock is a system file of Docker itself that allows container to manipulate other Docker containers and get some service information. But most important volume here, mounted to /results, is our results folders that will contain all the outcomes of executing different tasks. Finally, for Apache, the only service, we also have ports defined, and this line indicates that port 80 of the Apache container will be mapped to local port 80 of the virtual machine. You can read more about the syntax of both Dockerfile and Docker Compose on the web pages for Docker. Now we have this file configured. We can proceed creating the Docker server. To do that, we are going to run the following commands. Docker compose space up -d --build. This command starts containers. So first of all, it creates them, it starts them, and it detaches from the prompt or from the logs that they output, because we have specified this -d argument. Then --build ensures that if we have modified either containers or source files or Docker compose file or anything, it will also rebuild containers and stop old ones, remove them, and restarts the whole process for the modified container. You can see that it starts preparing the files and fetching actual images for MariaDB, which is our MySQL server. Then for make project container, it took quite a lot of time to create all the necessary images, but once they have been created once, they will never be recreated again. So if we ever to restart this server, then the images will be automatically reused. So we need to do a slight modification to this command, and we need to add URL_base equal to http://192.168.1.1.3080. And this would be the IP address which will be used as a base for all URL links on our web server for BOINC server. And as you can see, it caused a little bit of rebuilding, but not much. Most of the execution have been cached and reused successfully. And if we run it now it redirects to the correct IP address. And the only problem is that this file doesn't exist there. However, other parts like preferences and server status, they do work quite nicely. Let's add a task. To do that, we are going to use the following command. So what happens here? This is Docker Compose, and executes the command in the container a patch. The command is bash, which is a standard shell for Linux, and -c argument tells bash that it needs to execute the following as if it was run in the prompt. So we are calling this bin/boinc to docker create_work.py file, and we tell it to create a new instance for the following container. The container is the same name that we would use in the Docker repository if we were, for example, to pull it. And as you can see, it successfully reported that it downloaded this image, created input file, created template, and created a new work unit. This work unit is now part of the BOINC server. Another alternative way is to actually not just specify the container, but also specify the command that we want to execute. So we will execute input.py, and we will execute it in container 003, and we will pass some test argument. And it has been created successfully. Here are the steps that you need to take in order to cleanly rebuild your BOINC server. First, you need to stop your Docker containers by running docker compose stop inside BOINC server folder. Then you need to remove them by typing docker compose rm and confirming. And finally, you want to reset your volumes by using docker volume prune. Beware, this is a dangerous action, and if you haven't saved projects, they will be completely deleted. And I'm confirming that this is what I intend to do. Okay, now you can see that we have reset it, and now I can cleanly rebuild Docker with URL base that points towards my local IP address, so that I can run external computer to connect to my Docker server. And now that it is done, I will also use this docker compose exec to create a command for our Docker container. Let's try launching this in the client. In order to get BOINC client for Windows, you need to go into boinc.berkeley.edu/download_all.php and select download either BOINC itself or BOINC plus VirtualBox. The choice depends on whether you have VirtualBox installed, and you must have VirtualBox installed in order to be able to run these tasks. I will not do that because I'm using Ubuntu. The process of installation is very straightforward here, so I will not explain it in detail. The process of setting up projects, however, is very similar in both operating systems. So, in order to get BOINC in Ubuntu, you can use apt. So you need to do sudo apt install, and you will need to install BOINC-client and BOINC-manager. BOINC-manager is optional, but it is a convenient tool for user interface configuration of BOINC client. And I already have them installed, so the system just reports that. In order to start BOINC manager, under Ubuntu you need to type BOINC mgr and press enter. You will be immediately offered an option to join one of the existing projects, but since we are having our own, we will just type directly the project URL here. And this is my local IP address, and we need to add BOINC server at the end, and press next. And when the system connects to the server, you will be prompted whether you want to create a new user or use the existing credentials. Since I have restarted the server completely, the user has been deleted, so I'm creating a new account. Finish. And you are suggested to finish the account setup on your server IP address, but we're not going to do that. As you can see, the project has been added to our project list, and in the tasks, we now have two identical work packages, and you can see that they are different by 0 and 1. These are two copies of the same task. Each task by default is executed twice to ensure that there are no random errors. It is expected that the results will be identical. And you have seen some files being downloaded, primarily images for the VirtualBox and layers of our Docker images. And now you can see that one of the tasks has changed its status to running. And it will take some time to run this task, even though it is a rather simple problem because of all the overheads that we need to perform, such as creating Docker container, assembling Docker images, running the whole virtual machine that is necessary to run those Docker images. But it has been completed in 1 minute and 35 seconds. And as you can see, the status is ready to report. And if we go into our account on the web server, and use our login and password, you can see that we now have in our statistics still 0 credits, but this will be updated eventually. And you can see the tasks that have been computed by this client, by this account. You can see that work unit 1 and task 1 has been completed and is waiting for validation. Once the second part will be completed, it will be validated and the canonical result will be saved into the server results directory. Meanwhile, we can click on the task itself and go through the text logs of what has happened here. There is a lot of technical stuff that happens as wrapper to our problem, such as starting virtual machine. But eventually, we have this one line that is printed actually by our Docker image and our task. So if we would have had some kind of calculation running, we would have printed the result here, and we would have been able to see the result of calculation for this particular task in this particular block. And the other one is ready as well, and both of them have changed their status to completed and validated. Let's run in BOINC a simple application that will actually return some results. In order to do that, from a packaged application, you need to write some files into /root/share/results inside your Docker container. And in this case, we are writing hello.txt, and we'll write hello BOINC inside of that file. And this is sufficient to return the results of your execution as this file. This file will be preserved and it will be uploaded to the server, and it will be stored in the results folder, which we will see later. I have already had this file packaged as proper Docker image, so I will just run it. This is creator/mytestBOINC calculation version 002. And as you can see, it has been created with work unit starting with 581. A few minutes later, our BOINC client have detected the new task, downloaded it automatically, executed it, and posted the results to server. So how do they look like? If we go to cd/results, BOINC to Docker, we will see a folder that contains today's date, and inside that folder, we will see a new archive that has name BOINC to Docker _581, which corresponds to the name of our work package. Let's see what's inside of that archive. I will use Midnight Commander as a tool to browse inside of that archive. And as you can see inside, we have hello.txt file, which contains exactly what we asked our application to write in. So in this way, you can return data from your computations, and they will be all aggregated on the server and stored in the results folder. If you make this folder shared, they will be also directly copied outside of the virtual machine into your main operating system. We will go through more advanced examples of passing data to and from containers in practical exercises.